Hello everyone, this is Tiago from MaxxFlow. In this video, I want to share with you the MaxxFlow's calibration process using a simulator. MaxxFlow produces the most accurate and robust sensors for solids and gas measurement. So for those who don't know what a MaxxFlow is MaxxFlow's sensor for mass flow measurement of bulk solid materials, such as cement, gypsum, sand, and some kinds of grains. The MaxxFlow measures mass flow rates up to 300 tons an hour, and it is available in 3 different sizes: 100, 150, and 200 mil internal diameter. MaxxFlow must be always installed after a material conveying device, such as a screw feeder, a rotary feeder, or anything that moves material down to a free fall, where the sensor will be installed. This free fall can be totally in vertical or in a sliding angle. To do the MaxxFlow calibration, we can do in 2 different methods: using only the MSE300, the evaluation unit with touchscreen, or using the evaluation unit with your PC, connected by a USB cable. In my example here, we're gonna use the software, because everything through a simulation process. To do the calibration, we can do in 2 different methods: static or dynamic. Static, you basically fill the sensor with the material, and basically pressing one button, you tell this is a full sensor and it's basically ready to go. This calibration process is called easy full calibration. It considers that the sensor is loaded with material and the velocity measurement happens only after the calibration. And the most recommended method is called easy flow calibration, which happens dynamically. We have to convey material through the sensor and then store data and find calibration points. This is what we're gonna do here now. So jump into the application here. We have a process with the following characteristics. The nominal throughput is 47 tons an hour. This is what the customer wants to keep, but the flow can fluctuate from 40 tons an hour all the way to 50 tons an hour. The material bulk density is 1,520 grams per liter. And the diameter, in this case, the sensor selection in this case, is 150 millimeters. DN150 sensor. The sensor will be installed in a fall height with 0.5 meters. 500 millimeters from the falling point to where the sensor should be placed. Using this information, we can calculate how much of the cross-section will be occupied with material. In our application here, we have on a nominal throughput 15.52% how much of the pipe has been used, going from 13 up to 16.51% occupied. What does it mean? It means that only less than 20% of the pipe will be filled with material, loaded with material. In other words, on 50 tons an hour, on a DN150, we're gonna have 16.51% occupied. So it's a pretty safe application to do. No worries about clogging material, stopping the flow, stopping the process. It's a safe application. Okay, so this is how the software looks like. Using the USB cable, we connect the laptop to the evaluation unit, and we make sure we select the right COM port, device address, and baud rate. In our case here, we are selecting the COM port 4, which the sensor is connected. So, but still MSense, still information about the MSense. So I reselect here the COM port 9600 baud rate, read device, and then boom, configuration loaded. But it's MSense of moisture. This is not right. So it's the MSense sensor. No, should be the MaxxFlow here. And then we select here which sensor should be there. In our case, we change from MSense 2 to MaxxFlow. And then we're gonna do the easy flow calibration. So the dynamic calibration. Okay, we go to the measurement. We name the sensor according to the tag. In this case, MaxxFlow. Unit, tons, an hour. Could be second, minutes. Decimal point, you can adjust here. And then we do device program. From that point, the evaluation unit is ready to understand as a MaxxFlow, and you can see here we have the raw value, the quality measurement, we have the density, flow rate, velocity, and temperature information. You can reset the totalizer there. Just close the window. Okay. So here we have the set point, low and height, which we basically select according to the application. Okay. In our case, 50, maximum, device program again. And then we jump to the calibration point. This is how it looks like to do the calibration. The conveyor type is a free fall. And now I want to create a data logging file. So I select a place on my PC. I name the data logging file, and we go back to the software. MaxxFlow Calibration .csv. Online representation again. It opens the online representation screen and we select data logger activated. From this moment, it's gonna store the data which the sensor is reading, second by second. This is what we're gonna use to do the sensor calibration. At this point, I'll wait a little bit to provide some data, and then we open the file on Excel, and we're now able to check all of the parameters and even do a graphic relating the reading data and time. Okay, this is what the data logging file looks like. We have data, time, measured value, total, errors, and information about each sensor antenna inside of the MaxxFlow. Now we can create a graphic about the density readings raw value in time. So this is what looks like the density reading along the measurement. I was using and variating the simulator outside. It was an external device to do the simulation. Okay, now you see how the data logger looks like. I want to show you now how the mass flow, the 50 tons an hour, is related to the how much of the pipe is occupied. As you see here, 50 tons an hour should be 15.7% occupancy. It's the same number, 15, 16. So after checking the data, we could see that the application parameters, they are pretty much related to what the sensor is reading. Okay, let's get back to the online representation. Now we're gonna do it for good. Conveying material, data logger activate, and wait. Wait for a normal flow rate, normal operation. Just leave it there, storing data for some time, grab your coffee, and wait. At this moment, we don't have to worry about what the sensor is showing. You see, measured value is 4 tons an hour. It's not right because this is not yet calibrated, okay? So we're just storing data, Doesn't matter what the sensor is showing. After store the data, we're gonna do the calibration curve, do the average, and then rewrite the calibration parameters. Okay, that's good enough. Let's go again to our Excel file, our data logging file. Okay, from this point, you see, we delete here because that was the moment where I stopped. This information, gonna use density information. This one here, density information. How much of the sensor was occupied, certain flow rate. I'm gonna do here an average of all the density information, what the sensor saw in a normal conveying situation. So we're gonna write it here, the density. We copy the data and right here. So 5401.81. That's enough. In that situation, we had 47, the nominal flow rate, 47. So we write here 47 with the 50, the average device program. Boom. Good. Let's see how the sensor reacts now. Online representation again. Then what we have, 41, 42 tons an hour. 42, 43 tons an hour. And that's it. Done. We just use the density information. With only 1 point, it's enough to do a relatively good measured value. We have now 41, 42. We can, in the simulation, we can change We played a little bit with the simulator outside, and then we had a very big increasing in the flow rate. Now I'm adjusting again the simulator to achieve the same 50% occupancy. You see there, density 15.4%. This is the same value we saw in the calculation before, and it translates to 41 tons an hour. And now I want to change the simulation again to achieve the 16% level, which should stay around 50 tons an hour. You see, when the sensor density information reaches 16% occupied, the mass flow measurement goes to 50 tons an hour. This is what's showing there. How much is occupied, the density information, and the measured value. Stays a safe application, and a pretty good sensors response. And that's it. It's pretty much it. We basically place the sensor there, start recording data with a nominal flow rate, create an average of the stored data, write in the sensor again, and write the mass flow information. On our simulation here, we had the density simulation and velocity simulation, the two main measurements for a MaxxFlow. We simulated the material velocity, the falling material, and we simulate how much of the pipe was occupied. Yeah, that's it. I hope you guys enjoyed this quick tutorial how to calibrate the sensor. Once again, that was a simulation. We did everything using a simulator beside of the PC, not a real process, because in real process it may happen some velocity challenge we have to figure out, some mechanical challenge depending on the position, which makes better having someone with experience helping you to do the sensor commissioning. And finally, I hope you liked this video, you found value on it. And if you want to see more content like that, feel free to browse here on the channel. Please subscribe if you want to see more content like that, tutorials, application notes, and let's be in touch. If you have more questions about the MaxxFlow, how to install, how it looks like, the dimensions, I will leave here in the description the user manual, the product page, product data sheet, and for our entire portfolio of mass flow meters, such as solid flow, pico flow, and dense flow, everything here in the description. If you stayed to this point, thank you very much for watching, and see you next time with more solids measurement. Ciao, ciao!